Hi folks, welcome to 9.3 Geometric Sequences. So let's start off by talking about what is a geometric sequence. So a geometric sequence has to be a case where we have something called a common ratio, okay? And this common ratio, what it does is it takes one term and it multiplies it by this common ratio to get the next term, okay? So this is different from the arithmetic series in the sense that this R multiplies each term instead of adding to each term. Okay, so it multiplies, not adds. So when you have a list of numbers and you multiply by one number, the same number, to get from term to term to term, that is called a geometric sequence. And one way that you can find this common ratio is by using this equation. And this equation is really just saying you take one term and you divide it by the term that comes before, okay? So let's write that down, that this common ratio equals the ratio or the division between one term and the term, let's call it the previous term. Okay? So you're going to take one term, you divide it by the previous term, that will give you your common ratio. Now this common ratio, all right, can be any number, except it cannot be 0, all right? So this common ratio can't be 0 because we end up getting the same number over and over and over again, and that's not a geometric sequence, okay? R also cannot equal 1 by definition. So I want to add that in here because I think that's important to know that same thing, if we put 1 in for my common ratio, every single term is going to be the same. All right, so R cannot be 0 and R cannot be 1. Other than that, R can be any number that we want for the common ratio. It could be positive. It could be negative. It could be a whole number. It could be a fraction. And all of those options are okay. All right, so let's take a look at the formula for a geometric sequence. So in general, you can have a starting term, so that's our a sub 1, okay, that's our starting term. And what we're going to do is we're going to multiply that by r to the power of n minus 1, okay? So again, R is our common ratio, and N is whatever number we're looking for. And I just wanted to put parentheses around this to remind us that we have to do things using our order of operations, which means we have to take our common ratio, raise it to a power first, and then we're going to multiply by our starting term, okay? All right, so let's go ahead and take a look at these two examples. All right, so example number 1. If a sub 3 equals 5 and a sub 6 equals negative 40, find a sub 1, a sub 8, and r. Okay, so I'm going to draw a little bit of a diagram here. I know that my first term is going to be a sub 1, then I have a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, a sub 7, a sub 8. All right, so I just leave spaces for all of the numbers I have. And then I fill in the numbers that are given. So for example, a sub 3 equals 5, so I'm going to put a 5 here. And a sub 6 equals a negative 40, so I'm going to put that in the a sub 6 spot. Now, what am I trying to find? Well, I want to find a sub 1, I want to find a sub 8, and then I want to find the number that I'm going to multiply to get from one term to the other. So here's how we're going to approach this problem, okay? We're going to go ahead and write down our geometric sequence formula. So that is a sub n equals a sub 1 times r to the n minus 1. And what I'm going to do is I'm going to take the two numbers that I'm given. So I'm going to take a sub 3 equals 5 and a sub 6 equals negative 40. And I'm going to plug them both into this geometric equation. And then that's going to give me two equations, okay? So the first one is going to be 5 equals a sub 1 r to the 3 minus 1. So I'm putting in 3 for n because that's the number term that I'm looking for. And what is the term in the third spot? Well, that's 5, and that's why I have 5 here, okay? So let's clean this up a little bit. 5 equals a sub 1 r squared. Okay. Now, let's do the same thing for the a sub 6 term. So a sub 6 is negative 40, and so that equals a sub 1 r to the 6 minus 1, because negative 40 is in the 6th spot. And if we clean that up, we get negative 40 equals a sub 1 r to the 5th. All right. So now what we're going to do is we're going to take these two equations as a system of equations, and we're going to solve for r. So the thing I notice is that both equations have an a sub 1. And so I'm going to solve for a sub 1 in both equations, and then because they're both equal to a sub 1, I'm going to set them equal to each other. So a sub 1 equals 5 over r squared. And for this one, a sub 1 equals negative 40 over r to the 5th. And now we can see they're both equal to a sub 1, so I'm going to set 5 over r squared equal to negative 40 over r to the 5th. And I'm going to go ahead and multiply the r to the 5th to the left-hand side. And at the same time, I'm going to divide that negative 5 to the other side. So what does that give me? That gives me r cubed equals negative 8, which makes my common ratio equal to negative 2. Okay? So we found our common ratio, and I find that to be a good place to start with a lot of these problems is find your common ratio, or in an arithmetic sequence, find your common difference. Because once you have that, you can fill in all the terms. So for example, if I want to find a sub 4, I'm going to take a sub 3 and multiply it by negative 2. So 5 times negative 2 will give me negative 10. Take that, multiply it by negative 2 will give me 20. Take that, multiply it by negative 2, I get my negative 40, and then I get 80, and then I get negative 160. And so now I've found my a sub 8. Now, in order to find my a sub 1, I don't want to multiply by negative 2, but I'm going to do the opposite, which I'm going to divide by negative 2. So I get negative 5 halves, and then I divide that by 2 again, or negative 2, and I get 5 fourths as my a sub 1. Okay, so we found our a sub 1 as 5 fourths, we found our a sub 8 as negative 160, and we found our r to be negative 2. All right, let's go ahead and try one more problem that's similar to this and see what we get. So in example 2, we have a sub 4 and a sub 7, and they are 7 and 56 respectively. And now we want to find the same things, a sub 1, a sub 8, and r. So I'm going to set up my 8 spots. All right, so a sub 1, a sub 2, a sub 3, a sub 4, I can fill in a 7, a sub 5, a sub 6, a sub 7, I can fill in a 56, and a sub 8. Okay, so I'm going to do this problem exactly the same way. I'm going to set up my a sub n equals a sub 1 r to the n minus 1. I'm going to fill in 7 for a sub n and 4 for 1. And then separately, I'm going to fill in 56 for a sub n and 7 for n. So that will give me 7 equals a sub 1 r to the 4 minus 1, or 7 equals a sub 1 r to the third. Now, because I've already done a problem like this, I'm going to go ahead and isolate my a sub 1 right here. 7 over r cubed. Let's do the same thing for the 56. So 56 equals a sub 1 r to the 7 minus 1, or 56 equals a sub 1 r to the 6th, or a sub 1 equals 56 over r to the 6th. And now I'm going to go ahead and set these two equal to each other. So 7 over r cubed equals 56 over r to the 6th. At the same time, I'm going to multiply the r to the 6th, so r to the 6th over r cubed equals, and I'm going to divide by 7. 56 divided by 7. This will give me r cubed equals 8, or r equals 2. Okay? Now once we have our r, now we can fill in all our other terms. So 7 times 2 is 14. 14 times 2 is 28. 28 times 2 gives me 56. 56 times 2 gives me 112. And so 112 is my a sub 8. Now to find my a sub 1, I have to go backwards. So 7 divided by 2 gives me 7 halves. And then 7 fourths. And then 7 eighths. So my a sub 1 is 7 eighths. My a sub 8 is 112. And my common ratio for this is 2. Okay? So we're going to go ahead and stop here for the 9.3 video part 1. And when we come back in the second video, we're going to talk about not just sequences, but series, or when we add together terms in a geometric sequence. All right? I'll see you there.